Hello, everybody. I am still sick, so I'm sorry I sound so gross. I'm getting better, but I probably sound worse today. Anyway, we're gonna go ahead and get through this because it is a very short note packet. It's only one page front and back, so it should be a very quick video. Today, we're going to talk about solving systems by substitution. So last time we talked about solving systems of equations by graphing. Now we're going to do systems of equations by substitution, which is basically an algebra way of solving it. Okay? So, sorry, it's kind of wordy right now, but it's step by step how to do it. Okay? So, steps to solve a system by substitution. You're probably going to have to pause this video. Alright? Step 1. Set one of the equations equal to either the variables. So you can either set it equal to x or to y, whatever is easier. Plug in the expression that is equal to your variable in for the same variable in the other equation in the system. Solve for the remaining variable. Substitute the found value of one of your variables back into the given equations to find the second half of your solution. Check your solution by substituting the x and y values into all the equations in the system and make sure they give true statements. That is very, very wordy, and I'm sorry, so if you didn't finish writing it, pause the video. But it's going to make sense when we do it. Okay? So let's go ahead and try one. Alright, solve the following system by substitution. So here we go. We have 3x minus y equals 4. And x equals 5 minus 2y. So our first thing is to get one of the variables by itself in either equations. Well, this equation already has x by itself, so we're going to go ahead and use that. So by doing this, we know what x is equal to. Okay, so x is equal to 5 minus 2y. Since x is equal to this, we can go ahead and substitute it in for this x instead. So what we're going to do is we're going to say 3, instead of writing x, we're going to write what x is equal to. So 3 times 5 minus 2y minus y equals 4. We go ahead and simplify this. Well, simplify? We're going to go ahead and solve for y then, because that's the only variable left. So I go ahead and do 3 times 5 gives me 15. 3 times 2y gives me negative 6y. I have the minus y equals 4. I combine my like terms, so that becomes negative 7y. So now I have 15 minus 7y equals 4. Subtract 15 from both sides. I get negative 7y equals negative 11. Divide everything by negative 7. I end up getting y is equal to 11 sevenths. Now, this answer is very ugly, but it's true. Okay? Now that I know what one of my variables is, I can use that to find the other variable. So what I'm going to do is take 11 sevenths and plug it in for y into one of these two equations. It doesn't matter which one. I chose this one because then all I had to do is simplify this side and I get what x is equal to. But you can plug it in here and solve for x. It's totally fine. You should still get the same answer. So I plugged in 11 sevenths for y. So now I have 5 minus 2 times 11 sevenths. I multiplied this, 5 minus 22 sevenths, and then did the subtraction. I got 13 sevenths for x. So I have an x, I have a y, I now have my ordered pair. That's my solution. Okay? Again, it's a very ugly solution, but it works. And if I want, I can check it. I can plug it into the calculator if I want to and make sure I'm right. Okay? Or I could even plug it into the calculator and graph it and find the solution on the graphing calculator like I showed you in class. Okay? Did I give you guys any try on your own? Oh, okay, good. I thought I did it all. Alright, second one. Yeah. Find the solution to the following system. Okay, so here's the system. Step 1 is to get a variable by itself, but we already have that. So cool. We're going to take what y equals and plug it in for the y in the other equation. So now I have x minus 6. I multiply out this negative 1. So I have x minus x plus 6 equals 6. The x's end up canceling each other out, so I get 6 equals 6. Now, because that's true, what that means is that because it's a true statement and the variable is gone, it means it doesn't matter what x is, it'll always be true. So that means we actually have infinite solutions. When all the variables are gone and you're left with a true statement, it's infinite solutions. So this would be an example of overlapping lines. And if you graphed it, you would see they're the same line. Okay? Last one. We're going to try to find the solution to this one. We have y equals negative 4x plus 5 and y equals negative 4x minus 9. They're both already solved for y, so I can just pick which one to substitute in for the other. I'm going to take this negative 4x minus 9 and plug it in for this y up here. So I have negative 4x minus 9 equals negative 4x plus 5. I add 4x to both sides. I end up getting negative 9 equals 5, which is not true. When that happens and all the variables are gone, it means I have no solution. Okay? So if I graph this one, they would be parallel lines, meaning they're not going to intersect, so there's no ordered pair they have in common. You might have figured that out just by looking at the slopes. When they're the same slope, they're parallel lines. Okay? And the last thing is you have 2 to try on your own, and you need to do this by substitution. Okay? Now, you could easily use the graph or graphing calculator to check your answer if you want to. Okay? So, you're trying these 2 on your own, and if you have any questions, write them down. We will answer them in class, but that's it. Okay? And let's get this back up here. So you guys have a great day, okay? Bye.